Okay, this is section 11.5, an extra example separate from the lecture videos. So our problem here is the alternating series, the sum from n equals 1 to infinity of -1 to the n minus 1 divided by 4n plus 1. And of course, the question is, does it converge or diverge? So to satisfy the alternating series test, we would need to check, are the terms decreasing and is the limit of the terms 0? So before I do that though, I'm going to rewrite the question to look like the same format that we used in the section. So instead of having that -1 to the n minus 1 in the numerator of the fraction, I'm going to pull it out to be completely separate so that it's very clear to us what our b is. Okay, so now we have this in the format of the -1 raised to a power times bn, which means our b is 1 over 4n plus 1. Okay, so before we go or jump into the test, let's look at a couple of terms of this series just for fun. So remember, -1 to the n minus 1, the n minus 1 means that first term is positive because we have -1 to the 0. So what is our first term? -1 to the 0 times 1 over 4 plus 1. So, oh, sorry, we have 1/5 as our first term. So 1 over 5. Our second term would be n equals 2. So it would definitely be minus. That -1 to the 2 minus 1 would be negative. And then 1 over 4 times 2 plus 1. So that would be 1 over 9. Then back to positive. 1 over 4 times 3 plus 1 would be 13. Then we would have a negative again. 1 over 4 times 4 plus 1 would be 17. So if you look at the denominators here, basically we're adding 4 each time. So the next one would be 1 over 21, then 1 over 25, and so on. So that's what our series looks like. Now let's talk about the test. So Bn is 1 over 4 plus 1, 4n plus 1. And the question is, if you ignore the positive and negative signs, are these terms decreasing? Is each term larger than the next? Or is each term smaller than the one prior to it? Absolutely. You can see the denominator of each one of these fractions is growing. So if they were all positive, each term would be getting smaller and smaller and smaller and smaller. And remember, the way we write that is that bn plus 1 is greater than or equal to bn. And here, what does that look like? Bn plus 1 would be 4 times n plus 1 plus 1, which is 1 over 4n plus 5. So the question is that greater than or equal to b sub n, which is just 4 over or 1 over 4n plus 1? Yes, absolutely, because 5 is greater than 1. Okay, so we've confirmed that these terms are decreasing. Bn is decreasing each time. Now we need to know, is the limit 0? Is the limit of bn as n approaches infinity 0? So that question here would say limit as n approaches infinity 1 over 4n plus 1. What is that limit? Well, you tell me. We've done these several times, but basically the closest that this is to a term you're probably more familiar with is just 1 over n. We know that the limit as n approaches infinity of 1 over n equals 0. So can we use that here? Absolutely, right? The 4 is only going to make the denominator grow even faster than if it were just 1 over n. So this still, click the wrong button, this still goes to 0. 100% sure. And we can say because limit as n approaches infinity of 1 over n equals 0. Okay, so this series satisfies both conditions of the alternating series test, which means the series is convergent.